Let's take a look at the Quiz Yourself questions from Chapter 12.1. A, B, C, D, E, F, and G are finalists in a downhill ski race. Medals will be awarded for first and second place. In how many different ways can we award the two medals? Do this either by listing all possible pairs or by reasoning abstractly. If we list in pairs, letting the first place winner be the first letter and the second place winner be the second letter, then A, B, A, C, A, D, A, E, A, F, and A, G are all possible second place winners paired with A winning first. Now let's let B win. B, A, B, C, B, D, B, E, B, F, and B, G. C wins. A comes in second, or B. If D were to come in first, A could come in second, B could come in second, C could come in second, E, F, G. If E won, F could win and A could come in second, FB, FC, D, G, and finally, if G won, we could pair that with A, G, B, G, C, G, D, G, E, and G, F. We have 1, 2, 3, 4, 5, 6, 7 groups because there were 7 ways to award the first place. And in each choosing of a first place winner, we have 1, 2, 3, 4, 5, 6 possibilities, because after one person wins, there's only 6 possible possibilities for second place. So there's 7 possibilities for our first place winner, and once we pick a first place winner, there's 6 possibilities for our second place winner. And we listed out all 42 ways. And we also represented the abstract reasoning. How many ways are there to flip 4 coins? The way we'll visualize the answer to this question is through a tree diagram. Let's imagine the 4 coins are a penny, a nickel, a dime, and a quarter. Now we can visualize all of the possible outcomes. If we flip the penny, we'll either get a heads or a tails. And when we flip the nickel, the second coin, we'll also only get a head or a tail, regardless of what the outcome of the penny was. Now when we flip the dime, same thing. We can only get a heads or a tails. regardless of what the previous outcomes were. Notice for each previous outcome, we only have 2 options for the next coin, doubling the amount of outcomes we had previously. Each possible outcome will branch off into 2 more possibilities, because if the quarter lands heads, no matter which previous outcome, or if the quarter lands tails, regardless of which previous outcome. The quarter can only either be heads or tails. Now, how many outcomes are there? Well, the outcomes themselves are read by looking at the branches. So if you follow a path through each coin flip, this one, for example, I've highlighted, is H, H, T, H. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 of these possible outcomes. 16 possible outcomes for flipping 4 coins. How many ways are there to flip 4 coins? There are 16 ways. In Quiz Yourself 3, if we allowed the choices for players to be repeated in example 5, then we would have a different looking tree. They've given a tree diagram for no repetition. So our 12.4 figure for example 5 is a tree diagram representing all different ways to schedule 3 players without repetition. And we want to know how many branches would there have been in the tree diagram if we had allowed repetition. So for example, with repetition, the second game could have gone to any of the 3, just like the first game. In the first game, we could have E, P, or M. For the second game, now that repetition is allowed, we can have E, P, or M, regardless of what the outcome of the first game choice was. And our third game would again be 3 possible choices for each of the previous outcomes. Where any of E, P, or M could be chosen again. So our tree diagram looks like having 3 choices for game 1, having 3 choices for game 2, and having 3 choices for game 3. And we multiply these choices to get 27 branches. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 in the first third. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 in the middle group. And 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 more outcomes for this last group. Again, summing to 27 branches. How many branches would there have been? 27. In Quiz Yourself 4, we're asked, how many outfits could you have in example 6 if you had 4 tops, 2 pairs of pants, and 3 jackets? So if you had 4 tops, 2 pairs of pants, and 3 jackets, you might have started a tree that would look like having 4 choices for your tops and branching out to have 2 choices for your pants at this point having 1, 2, 3, 4, 5, 6, 7, 8 top pants combinations that you now will pair with one of the 3 jackets. You can see from the partial tree that we had 4 options for tops. We had 2 options for pants, giving us at that point 8 top pant combos. For each pant top combo, we could choose one of the 3 jackets, giving us a total of 24 outfits. Now, we're getting to the point where all we have to do is imagine the number of branches in the tree diagram, because from the 4 tops we knew to draw 4 choices, and from the 2 pants we knew to give each of our 4 top choices 2 pant choices, and so on and so on. And these trees get big fast, and so we prefer just to visualize them.